Welcome. I want to take a look at another example solving a system of equations using the method of elimination or addition. In this case, if I were to add the two equations together, it would not eliminate a variable. What I need to do is I need to multiply each of these equations by something. So I can, for example, make the coefficients on x match, but one negative of the other. I can do that. If I wanted them both to be 10, I could multiply by 2 here. Of course, multiply by 2 on the left and the right, which is just generally denoted by multiply by 2. And here, if I wanted to make it that 10 and make it a negative 10, multiply by a negative 5 on both sides, which is just generally noted by multiply by negative 5. When I write this, it is understood to mean that I am multiplying both sides of this equation by 2 and multiplying both sides of this equation by negative 5. Now, that doesn't change either equation in terms of what its solutions are. Therefore, it doesn't change the system of equations and what its solution is. So we end up with what's called an equivalent system of equations. So when I multiply by 2 for our first equation, I get 10x plus 6y is equal to 18. When I multiply the second equation by negative 5, I get negative 10x plus 20y is equal to negative 70. Here, I can add the two equations together. 10 minus 10x's gives me no more x's. 6 plus 20y's gives me 26y's. 18 minus 70 is a negative 52. I can divide both sides of this equality by 26 to get y is equal to negative 2. At this point, I can use either one of the equations to find the value of x. I'm going to use the second equation. 2x minus 4 times a negative 2 is equal to 14. So 2x plus 8 is equal to 14. Subtract 8 to find 2x is equal to 6. And divide by 2 to get x is equal to 3. This gives us a solution of x comma y is 3 comma negative 2. Excellent.